polynomial is exactly what's in example A. There's two polynomials here. So a polynomial is pretty much a quadratic function that has extra powers. So it's called a polynomial. But any function with a power to it is a polynomial function, and that power has to be a positive power. So our goal here in example 1, A and B, is to add, and it shows you that we can add vertically and horizontally. Just to give you an idea is that you can do this problem two different ways, and it's what you feel more comfortable with. So when you add polynomials, Ella, how do you think you would approach letter A for adding these polynomials?
I think when you add them, like with the 3x and the x, it would become 4x to the third.
Yeah. What are those numbers in front called that you added together, Ella?
Coefficients.
Yeah, you're just adding the coefficients. And the x cubes are like terms, so you're adding them together. So Ella, how about the rest of it? What else would we have?
Negative 7x squared plus 4x minus 3.
Exactly. So there is no x here, so we would just have that 4x. You're kind of just bringing it down. And then you're combining the last constant term. So a number by itself is considered a constant. Nice job, Ella. So that is all you do when you're adding polynomials. So a polynomial is just a big expression with a lot of powers. You add the like terms together. Now, vertically, it's pretty easy to do. If you look at it horizontally, it can be done exactly the same way. You just have to make sure you're combining the like terms together, which means the variable and the exponent must be the same. So kind of attach the correct like terms together. There's parentheses only to represent the fact that you have two different polynomials. Those parentheses do not need multiplication because there's an addition sign in between there. So Jordan, what do you think you would get here when you add your like terms together?
2y cubed, 3y squared.
Yeah, so there's my y squared. So she said 3 of them. What else do we have?
Minus 3y.
And then?
And minus 9.
Yeah. So if you need to group them together visually, you can box the two that are the same, circle two that are the same. But again, you're combining the like terms. The exponent and the variable must be the same. And that's it. Like there's nothing else to adding polynomials. It's really, you could say it's adding like terms. All right, so the next set we have subtracting, which is exactly the same, except we have to worry about the negative sign. When you're subtracting a polynomial, you're subtracting the entire thing, which means that this negative sign needs to affect everything inside of it. So the first equation is staying the same because that we're not subtracting. We're subtracting the second equation. So it would become a negative 6x cubed, negative 3x squared, and then that's a positive 7x. Be careful with that because there is already a negative in front of the 7x. And then we have a negative 5. So once you have them lined up vertically, you're pretty much combining them exactly as they're listed. So technically, there's a plus sign outside here now. You distributed the negative through, and now you're just kind of combining them vertically down. Riley, what would this look like if we add our like terms together?
You'd have x cubed minus 9x squared.
You're good so far.
Plus 4x plus 2.
Perfect. So again, you're just combining them as they are listed. So when you distribute a negative through, you're taking the negative to everything. There's really a plus sign sitting outside there because you're still adding those pieces together. Does anyone have questions?
Miss Kane, can you go up to the first problem? I think I wrote it down wrong.
Example 1 or 2?
One, but I got it.
Okay, you good?
Thank you.
Yep, just want to make
Yep, I'm
sure.
good.
Okay. All right, so for example 2b, again, we have this minus sign. The parentheses do not mean multiplication. They're just there as grouping symbols. Sometimes parentheses just group things together. So I'm going to do this 2 steps here. The first one is going to stay the same. The second one, I'm going to distribute this minus sign through. That minus sign, once you distribute it through, you're really now taking this polynomial and adding it with this polynomial, which is exactly what we did up here. Because a minus sign is really saying I'm adding a -1 times a quantity. So there's still 2 polynomials there, 2 big expressions, and then you're adding their like terms. So Ava R, if you add those like terms in that part B, what would you get?
So you would get -4x squared plus 4x and plus 14.
Awesome. Nice job. So if you go down to the bottom of the page, see if you can do those 2 problems. And it says use a setup of your choice. So if you like lining them up vertically, line them up vertically. If you're okay just having them spread out horizontally, you can keep them horizontal. So it's your choice. Add those together. Find the sum or difference. Just make sure you're combining those like terms together, especially for the first one. First one is kind of written out of order. So if I were rewriting this, I would kind of make sure that I have the polynomial written in the order of the powers, and that's how your answer should always be. So your answer should start with the largest power and they should descend in order. So again, here's one polynomial, there's the second. I just kept mine in vertical, or I'm sorry, horizontal form, but you could do whatever you like. Helene, what do you get for number 1?
I got -2t cubed minus 2t squared plus 8t plus 13.
And you are super close. That last 7 becomes negative once you distribute the minus through. So it's going to
-1.
There you go, a -1. So she gave it to me in order. The powers descend, starting with the largest power, combined all the like terms. Does anyone have questions? So the last one is just plus. Again, make sure that you're looking. That is just a plus sign. We're just adding these together. So Gabby Soul, what do you get when you add number 2 together, those polynomials?
12p squared minus 13p minus 2.
Awesome. There we go. Nice job. Any questions? Pretty straightforward, hopefully. Okay, so we already did adding and subtracting. Done. The last thing we have to do is some multiplying, and that's what the back page is. So the next side, I guess not really the back page unless you have a physical piece of paper, the next slide in your packet wants us to multiply. And we're going to be multiplying horizontally. And if you look down the page, you see we have a little different than foiling. Foiling is when you have two terms, x plus 3, times another two terms, x minus 2. That's called a binomial times a binomial. In number 3, notice that we're multiplying two pieces and three pieces together, or two terms, a binomial, three terms, a trinomial. Valerio, how do you think we would try and multiply example 3a?
Would you distribute the x to each term and then distribute the -3 to each term?
Yeah, and that's exactly the perfect word to use. So we cannot use FOIL because FOIL is just four numbers we're multiplying together. Instead, you are going to distribute. So that x gets paired with every single one of the values in the back. Valerio, what does that become when you pair them together?
X cubed plus 2x squared minus 5x.
And then, Valerio, if we take the second value, the -3, what do you get when you multiply those together?
-3x squared minus 6x plus 15.
Nice job. Now, I'm going to line mine up vertically. You do not have to do this, but mine is more because I wrote too big and I ran out of space. Sometimes lining them up vertically, though, helps, because if you line these up vertically, you have your like terms that are paired together right underneath each other. So, Valerio, final answer here. If we add these together, what do we get?
X cubed minus x squared minus 11x plus 15.
Awesome. Nice job. So you're really using the distributive property. We're distributing each term to the values behind it. Questions? All right, so if you look at part B, you can do this two ways. You could take the x squared and distribute it. You could take the -3x and distribute it. And then you could take the 10 and distribute it. That would be way number 1. The second way would be to start in the back and multiply forward, taking the x and going forward, and then taking the 1 and going forward, so that you're kind of multiplying it like we did part A. Again, it's totally your choice. You get two ways to multiply. And it's what makes it easiest for you, what makes the most sense for you. So you're still distributing. It just depends on how you want to distribute it through. Grace, how do you think you want to distribute this problem?
I guess the backwards, so it'll be the same as the last one.
Yeah, I think that's the way I'd prefer to do it. What do you get when you distribute x then, Grace?
It'll be x cubed minus 3x plus 10.
And that has a little x next to it.
Oh, yeah. And then x squared minus 3x plus 10 for the second one.
Yeah. So distributing the x to everything and then distributing the 1. And when you distribute a 1, we know it stays the same. Again, I lined mine up vertically, so I'm just going to add vertically. And when you add, bring down the x cubed. We have a -3x squared and a 1x squared, so that makes -2. 10x minus 3x is 7x, and then 10. Questions? All right, so we have one last example, and then there's one practice problem down below. As I said, pretty short day of notes for today. So this last set of examples wants us to multiply 3 binomials together. So you can see a binomial has 2 terms, a trinomial has 3 terms. So now this is saying multiply 3 binomials together. Jaden, how do you think you would do that?
Would you have to distribute each binomial into all the other two?
Can you
So like, would you take like x minus 3 and distribute it into x plus 7 and x plus 1? And then would you take x plus 7 and distribute it like x minus 3 and then x plus 1 and then x plus 1 into x minus 3 and x plus 7?
so I think you're making it more work than it needs to be.
Okay.
So think easier. What
Would you
else?
just have to distribute one of them into the other two?
So yes. Because when you're multiplying, once you multiply one thing by something else, it's already in that, it's been absorbed. Think of it as like I'm multiplying, so it's absorbed into that second thing. And now it's already in that. So if you pair two of these together, Jaden, so I box the first two together, what would you do with those first two? If I just paired the two that are next to each other together, how would you multiply those, Jaden?
You would just do x, like you would distribute them or foil them, I guess.
Foil them. Yeah, you just foil them. Yeah, so what do you get when you foil them?
It would be x squared minus 3x plus 7x minus 21.
And then we can combine and we get a 4x in the middle and then minus 21. So that's the first pair. That pair now is a new polynomial, or it's a quadratic function. So those two were like combined together, and this is their product. This is their resulting product. You're going to take the other remaining and bring that down. So we still have x plus 1 that remains. So because we multiplied those two together, I'm going to multiply it with that remaining part because the answer is the product. It's already combined together, so we don't need to do any extra multiplying. And you can choose to work from the back forward, kind of up to you. So this is like a two-step multiplying. You're going to be really good at multiplying today. So if I multiply from the back forward, I get x cubed, 4x squared, and then minus 21x, because I'm just multiplying everything by x. So my powers should change, but not the numbers. And then I have to multiply everything with a 1. Well, multiplying by a 1 remains the same. So I have an x squared, a 4x, and then a minus 21. And notice I'm again lining these up vertically. I like to line them up vertically because then it's neat and organized and everything is put together for you. So if you take the extra maybe 10 seconds to line things vertically, then everything is already together for you. Kind of like elimination. When we eliminate, terms are lined up in the vertical form. So I have x cubed plus 5x minus 17x and then minus 21. So if you haven't started B, see if you can do B. And then there's just that independent practice. And you can choose to multiply any two pair together. Multiplication is called commutative. So I can multiply the first two pairs together. I could multiply the last two pairs together. Again, that's up to you. Zach, do you have example 4 part B done?
Yeah.
Okay, so which way did you distribute?
I distributed like with the little one towards the big one.
Yep, perfect. So what did you get for that?
I got x cubed plus 2x squared minus 8x,
Good. And then the next one?
and then negative 8x squared minus 16x plus 64.
Awesome. And then your final answer, what do you have here?
X cubed minus 6x squared minus 24x plus 64.
Nice job, Zach. So I don't think these problems are challenging. They're just tricky, making sure that 1, you're using all your multiplication facts, and then 2, you're combining them together correctly. So you could make little tiny mistakes. That would be the problem with these. Easy to make a little mistake if you're not adding correctly, you're not multiplying correctly. Any questions on B? So our last one, I multiplied the first 2 together again. And then we have this x squared minus 4x minus 5. And then we're multiplying that with x plus 3. So Annabelle, what do you have here?
I have x to the third minus 2x squared minus 15x. And then under it, x squared minus 2x minus 15. Oh wait, I multiplied them by
The other way.
yeah.
Okay. Sorry. Did you multiply the last 2 together?
Yeah.
Yeah.
I multiplied the first one and the last one together.
Oh, well, that's interesting too. Okay. Are you willing to try and multiply how I have it written?
Yeah. It would be x to the third minus 4x squared minus 5x.
And then the next 3.
3x to 3x squared minus 12x minus 15.
Nice job. And let's see if you get the same answer. So you have x cubed, and then what did you have?
Minus 2x squared. Okay, minus x squared.
Uh-huh.
Minus 17x minus 15.
There you go. Did you get the same answer doing it your way?
Yeah.
Yeah, nice. So she chose to take the first one and the last one and multiply those together. And then she multiplied by the middle, but you still get the same exact answer. So it's totally up to you what you see and how you want to multiply them together. But that's the great thing about multiplication. So as long as you're pairing 2 of them together and multiplying with the remaining, you have that final solution. Does anybody have questions? As I said, short day today. On Monday, we're going to continue to multiply, but we're going to try and use some patterns to multiply. But we're still going to multiply polynomials together on Monday. Any questions? This is a nice little reprieve from the intense concepts that we did in chapter 4. So just a little reminder. Your homework, I chose to do the multiples of 3. So 3 to 36 multiples of 3. That means you're doing 3, 6, 9, 12, 15, 18, 21. So all of those multiples of 3. I'm going to make you work a little bit to decide which numbers are multiples of 3 instead of just saying the odds. And then the 65 to 72. Those are a couple of review problems just to keep you fresh with reviewing different problems. So what I'd like you to do right now is to go to Google Classroom.